Hello, hi guys, welcome to the channel. I hope everyone are doing great and I'm also doing good. So, in this video, I'm gonna explain how a broadcast giant has skewed my job. It actually increased my job execution time. So, I know that broadcast giant is going to avoid the shuffling process and it will improve the giant performance. But in my case, broadcast giant has skewed up everything and it spoiled my job execution time. I can explain you more details in the video. So without further delay, let's get started. Okay. So in this video, we are going to talk about broadcast giant. What is a giant? So usually in the Spark, join is nothing but to join the two different data set based on a common key. Let assume it we have an employee table, we have an employee table, and we have a department table. Okay. So in employee table, we have the department ID. Just assume it we have a department ID, and in the department side as well we have a department ID. Okay, so when you try to join based on this department ID equal to department ID, how the join is going to happen internally, the Spark is like, let us assume it on the employee side we have a department ID like 1 1 1 2 and 3. Similarly on the department side we can have 1 2 3. So whenever we perform any of the join in the Spark, so basically what it does, it will actually group all these ones into one partition, and 2 will be one partition, and all 3 will be one partition, right? Similarly, in the department also, it will partition like this. Okay. So all ones will be moved to one particular partition, right? 1 1 1 1. Okay, and then the join is going to perform. So by default, we are going to join with sortmerge join. Sortmerge join. It is a self-explanatory. Like it will first sort the data. Like once we fetch the data from the partition, it will sort the data and it will merge. Like it will sort the data and will move the two same data sets into one particular partition, and it will join. Okay. Similarly on the 2 side as well. Like it will join 2 and 2 from the department ID. Similarly, 3. This 3 will be joined with the 3. So this is how the joining is going to happen. If you clearly observe, in this step, we have a shuffle process, right? So what is meant by the shuffle process is like it has to fetch the data and it has to combine all the grouped data into one particular partition from both data sets. So this process is nothing but shuffling process. Shuffle. So in shuffle, we have a 2 steps: shuffle read, shuffle write. So whenever we read the data and we can write into some particular shuffle or temporary location. So this will be read by the some other partition, right? So to do this shuffle, lot of things going to happen on the background. One is like it requires lot of CPU cycle to do sorting and to identify which particular uh, block of data or elements need to be keep into one partition and all. And also it requires lot of input output operation. Like every time we have to move the data to the disk, and then during this process it will write to some disk, and then another processor will read the data from the disk, right? So it requires output, and also it will require network input output operations. Like since we are working in a distributed environment, so we have a multiple systems and multiple executors, right? So if you want to copy the data from between this, we need a network input output operation. So because of all these three things, shuffling is a costly operation. So this is the reason shuffling takes a lot of time to do a join. right? So to avoid this process, we'll use the broadcast join. So now we can understand what is meant by the broadcast join, right? So let's assume it we have a system that is in the driver node. This is the driver node, and we have two executor. Let's assume we have a two executor. So usually Spark works in the master and the slave architecture, right? So these are the drivers and these are the worker nodes, worker or executors. Okay. So we have one larger data set. We have one large data set. Let's assume in our case, employee is the larger data set and it has around some 10 GB. Okay. And we have a department table and this has around like 10 MB, right? So in this scenario, what we are going to do is we can tell the system or we can tell to the Spark that we can use the broadcast join of this department table. So what is meant by the department table is, right? So whenever it finds a smaller partition, so department table will be available in both worker 1 and worker 2 nodes. Okay. So whenever we call it as a broadcast join, it will actually, these smaller partitions will be pulled by the driver. Okay. So in the driver, it will be collected. Driver will be collected. Okay. So whenever the driver will be collected, we'll combine these two partitions, right? So we'll combine these two partition and we make it into one particular partition. So we need some sufficient memory here, and driver will compute hash map out of it. Okay. It will compute the hash map. It requires some sort of a CPU as well. So once it generates the hash map, it will broadcast again this hash map to the all the worker nodes. Okay. And this will be removed. This will be removed and this will be placed under this all the worker nodes. So now all the data, like in employee table, we have a multiple partitions here, but department we have a full-fledged partition, means all the table data will be available in same node. Here also the same way, like employee partitions will be available in the worker node and full-fledged department table will be available. So now we no need to do any of the shuffling. If you wanted to do join, since all the data available in a single JVM with the different partitions, it will directly join with the department table and can produce the results. So in this step, if you see, there is no shuffling. Okay, there is no shuffling. But if you observe the con side of this one is, we all the partitions of smaller data set will be pulled by the driver. Okay, and then driver will generate a hash map out of it and it will send the same hash map data to all the executors, and it also required some overhead. Okay, so your driver should have a sufficient memory to handle this hash map plus overhead, and your executor memory also will be consumed by this smaller data set. Okay, so if we have only one table, that is well and good and it works fine. What if it has like 100 tables? So usually in the real time, we don't have only one table, right? When you write a sequels, we have a multiple tables. Suppose if we have 100 tables, this 100 tables will be multiplied with 10 MB, it will close to 1 GB, right? So if your driver do not have a sufficient memory of 1 GB, it will fail. Or even in the executor, if any particular executor do not have enough memory, it will also fail. And the second thing, the 1 GB memory will be placed in across all the executors. So 1 GB is not going to utilized by any other process because it is already cached in the worker nodes. So in the remaining memory itself will be used for the computation, right? So that is the reason we have to choose rightly, like which table has to do the broadcast join. configure this broadcast join wrongly, like in this case, so this is going to skew up your join. This actually adds so much delay because it has to copy all the data to the driver, and if it find the right memory, it will spill to the disk and the memory, and it will take a lot of time over there. And it has to do hash map, and then it has to transfer all the hash map to all other worker nodes. This also includes some IO operations, network IO operations, right? So now let me tell you what I have done to make my job performance behave in worst compared to earlier. Like I got a job and that has a multiple sequels, like multiple sequel it has, and it is having some complex you know complex SQLs, and it includes the multiple joins, and I do not know each size of the each table, but I just checked the few table sizes, and I understand that few tables are in size something like, some is like 60 MB, some is like 100 MB, and some are like 80 MB, something like that. So what I have done instead, usually by default auto threshold broadcast join will be 100 MB. Okay, so that is a default config. So what I have done, instead 10 MB, I make it as 120 MB, because I thought all the tables fall into the 120 MB will be converted as broadcast join and it will execute. Okay, so what it done internally, like we, as I said, it has a multiple tables, right? So it combined all the tables and it send all the data to the driver. Okay, and it is failed on the driver side. Driver executed memory, something OIM related error that I have received. So next time what I have done, I just increase the memory on the driver side and just rerun. So this time I face the issue on the executor side. Why? Because in the executor side, it is occupied almost 120 MB. Like it will combine all the size of file. What I thought was it will take only 128 MB 120 MB of cached data, but that was not going to happen, right? Because if you combine all these things, 60 plus 100 plus 80, so it will be around 240, right? So 240 MB of the data will be cached in the driver memory, so remaining only memory will be used for the computation. So since I left only with smaller portion of the computation power to process my data, my jobs are getting failed, or it will take long time. So actually it is taking a long time to process, and then it is failing out. So later I realized that we should not increase the driver memory in such. So instead, if I remove this configuration as like 128 MB and I kept like 10 MB and I ran, it is running fine. At least it is running. This time it is failing and it is taking long time and it is failing. This time is with the help of sortmerge join, it is at least running. So this is a mistake that I have done it. So mostly even in the projects also, we do write a lot of SQLs and it has a multiple tables and all the tables fall into the different sizes of the ranges. So you should carefully take the value of the broadcast threshold value. Okay, so if you take some random value and try it out, so that will leads to failure and makes your job much slower because of the reasons that I have already explained in earlier of this video. Okay, so please don't do this mistake again as like me, and choose your broadcast threshold join wisely. I hope you like the content. If you like the content, please give a like and comment if you have any doubts or anything or any feedback to the comment below, and please do subscribe for more such informative related videos, and that also gives me some support to me to make such content. Thank you.